Welcome viewers. In this video, we are going to look at structural components for warehouse structures. From this video onwards, we are going to more focus on steel structure for warehouse building. So let me look into that structural components for steel warehouse. So first it was start with a column, followed by rafter, wall tie beams, roof purlins, cross bracings, connections, sag rods, corbel beams, crane beams, and finally the foundations. So here the major 9 number of structural components are listed here. Not only the structural components are limited to this 9, there are also several other structural components which may be missed in this list. So those structural components can be decided according to the structural building. So finally that from the last third, the corbel beams and the crane beams, which are also applicable only where the buildings is having the crane movement or the lifting hook option. So for these two provisions only the corbel beams and crane beams are applicable, not all the steel structures for warehouse. So now let me look shortly what are these 9 number of members. So from the pictures showing in the right hand side, you can see that there are a structural frame of the building, where the first one is a column which is a vertical member placing towards the span of the beam. Not only that, there is also wind post we need to place in the width direction. You can see this column which is supporting in shorter directions or parallel to perpendicular to span of the rafter. So the rafter is a top member. So coming to the rafter, generally this rafter used to place inclined at the top of the column, which is to hold the purlins. So this main purpose is to hold the roof members and the roof claddings. Generally it is inclined from 5 degrees to 10 degrees or even more than that. Sometimes it can be placed flat also. It's depend upon the environmental condition. Coming to the wall tie beams are tied between the columns along the length or in the width direction also sometimes. So this is to hold the wall claddings. Roof purlins, similar like the wall claddings, wall tie beams, it should be placed in the top of the rafter, which is to connect the roof claddings. So this will transfer the loads from the roof cladding to the rafter. Similarly, the wall tie beams used to transfer the wall claddings load to the columns, and also the wind load which is developed to the closed wall claddings. So those loads also transferred from wall tie to the column. Next, coming to the cross bracing. Generally this cross bracing used to provide laterally to the column or rafter at the top. So this main purpose is to maintain the stability, to increase the stability of the column and the rafter. This usually to be provided in between the column and the rafter to reduce their span or the length in terms of slenderness. Next, we can look into the connections. There are various type of connections for the steel buildings according to the requirement of the members to be connected. However, we have listed some 4 major connections here. In that, first one is a column rafter connections, which is to hold the rafter and the column by connecting with the bolt and plates, connection plates. Sometimes due to the higher span of the rafter, this haunch portion is required, which is in golden color. So the purpose of these haunches is to transfer the exact moment from the rafter to the column in the way of distribution of higher area. Also, sometimes this rafter, if it is going for a more span than 5 meter, then it requires more number of bolts, connection bolts. So here you can see that there are 6 number of bolts. However, the depth of the rafter will not have the enough space to accommodate the number of bolts. So in this way, in this method also we used to do haunches to support more number of bolts. So these are the main reasons we are providing for haunches. Next to the rafter ridge connections. Suppose if the rafter is going more span, so in order to connect this rafter, we need to provide the haunches, similar like what we have discussed in column and rafter connections. Also this bolt, if the number of bolts is unable to accommodate within the depth of the beam, rafter beam, then we need to provide the haunches by extending these connection plates. In case if the rafter span is less than the 5 meter or accommodate to hold the bolts with the 3 numbers to the depth of the rafter, then we can go in order without haunches, or even sometimes we can avoid these bolt connections also by providing the beveled weld towards the connection point of the rafters. So this is based upon the span of the rafter and the loads which is transferred between the two rafters at the ridge. So based upon these decisions, we can go with the connection types, either it is a welded or bolted. But in case of column rafter, we cannot go with the welded type because this can be easy in installations. Even though the span is less, we can avoid the haunches, but we should not go for welded connections because this column part will come separately and this rafter parts will come separately. So in order to ease the installation, so we need to go with the bolted connections for column rafters only, either to avoid the weld connections in order to do the installation faster. The third type is cross bracing gusset connections. So this green color plate called gusset plates. So this requirement of gusset plates is based upon the number of bolts and the connection materials, connection members. If the connections members is having enough flange width to hold the 2 number of bolts, then this gusset plates cannot be required. Also sometimes if there are more number of members to be connected to the main member, then the gusset plate requirement also needed. So it's depend upon the members which is to be connected. Also the number of bolts required to connect that. So depends upon that the gusset connections can be decided. Generally these angle members are subject to axial forces. So these connections used to design for axial tension, compression and shear. Remaining the earlier rafter ridge and column beam connections are subjected to moment connections. Finally, in this connections chapter, we are going to look the column, base plate and anchor connections. So this is a major things which is connecting the structural column to the foundations. So generally this base plate used to design for the pinned connections for the column, where it is transferring the axial forces, lateral forces, and some uplift due to the wind actions. So considering all this, we need to design the base plate. Also the lever arm distance of anchor bolt to the base plate and the projection outside the column will cause the bending moment in the base plate. So that also we need to consider while doing the design of base plates. Also, if any eccentric loading from the column, if suppose this column used to place somewhere at a distance away from the base plate center line, then it will cause a eccentric movement also. So that movement also used to consider while doing the design of base plate connections. So this base plate used to design based upon the acting force and the resistant force from the concrete pedestal. So in this way we need to find out the bearing area which is to resist between the resistant force from the concrete and the load transfer from the downward loads transfer from the structures. So by this way we can able to arrive the size of the base plate, and also the thickness of the base plate can be arrived from the lever arm distance and the reactions, support reactions from the concrete or the anchor bolt. By the two way we can able to analyze the base plate thickness. And coming to the anchor bolt connections, there are various checks we need to do for the anchor bolt. That is actual force, actual tension we need to consider while calculating the embedded length, and the bending stress we need to check in order to arrive the diameter of the anchor bolt. So likewise there are certain checks we need to do for base plate and anchor bolt connections. So these are the four major connections which we have seen in this chapter. Not only this, there are also additional connections such as splice connections, which is required to connect the same member which is going more than the available length, so that we need to break the length. Suppose if this rafter is having the span of more than 12 meter, sometimes the steel members is not available more than 12 meter. Some countries used to provide even the 28 meter of spans. So in that case there is no splice is required. But in terms of having a reduced length, say for example about 12 meter, then if the rafter span is going more than 12 meter or 18 meter, then we need to break at some length, either it can be 9 meter, and in that area we need to provide some splice connections. If the length of the member which we are provided in the building structures is available at site, then there is no requirement of splice connections. Coming to the sag rods, as you know that the wall ties and the roof ties are connecting between the column and the rafter. Due to the heavier span, the column, the wall tie and the roof tie used to bend little bit. This will cause some deflection, and also this will affect the structural claddings also. So in order to avoid these deflections, we need to provide sag rods in between the span of the wall tie or the roof tie. So generally this wall tie used to have a light material, either it is a cold form secondary steel or some hard form steel members. But however, this cross section of the steel members used to be very less, so we cannot go beyond the heavier sections. If we are going for the heavier sections, then the structural loads to the column or the structural loads to the rafter will increase more. So in order to avoid that, we need to provide the sag rod so that the span can be reduced. So this vertical members in cyan color, you can see these are the sag rods which is to be placed in between the span of the wall tie or the roof tie. So the main purpose is to reduce the length of the wall tie or the roof purlin. So generally, if this is going for 5 meter, then we need to provide a wall tie in between the sag rod in between the wall tie. The number of sag rod in between the span of the wall tie or the purlin is to be decided according to the span and the sections, cross sections which we are going to use for the wall tie or the purlin. Generally it will range from 1 to 3. So 1 means we need to provide at the midspan of the wall tie or the purlin. If it is 2 means either we need to provide 1/3, and if it is 3 means we need to provide as a 1/4 of the span of wall tie or the purlins. So this is to reduce the length of the wall tie and the purlin. In the right hand side you can see the detailed view of sag rod. So sag rod is nothing but it is a long span bolt connections between the wall tie or the purlin. So generally it will have a long bolt with nuts and washers. Either the nuts and washers may be 1 or 2 at either ends. It's depend upon the requirement. Next, coming to the corbel beams. So as I said earlier, these corbel beams and crane beams are applicable only for the steel structure buildings where the crane or lifting hook requirement is required. So in this picture you can see that the projected green color beams are the corbel beams which are to hold the crane beams which is above the corbel beams. So generally this to be connected according to the load which is transferred over these corbel beams using the crane beams. So the crane capacity is a major things which is playing the connections for these corbel beams. So this number of bolts required will decide whether this corbel beam required haunches. So here this crane capacity is up to 10 ton. So we have decided to go for 9 number of bolts as per the design. So this required haunches to hold these bolts. Also the stiffness between the flanges, in the flanges and the web is provided. So this is to hold the heavy crane capacity. Coming to the crane beams, so you can see these yellow color beams which is having the stiffener to the web, which is also having the inverted channel or C profile or U profile over the yellow color beam. So this set we can call it as crane beams. So this is also applicable where the crane provisions is required inside the building, and over this the rail beams you can see here which is in cyan color. So generally this crane beam used to run throughout the beam or restricted to certain length inside the beam. It depends upon the requirement of the lifting and the transportation inside the building. So these are all about the corbel and crane beams. Next we can look into the foundations. So foundation, we all know there are different types of foundations based upon the soil criteria, like shallow foundations or pile foundations or grillage foundations based upon the material to be used, either it is a concrete or steel. And in this we are going to look the basic things of foundations required for the warehouse structures. So generally in this screen you can see that single isolated foundations and the combined foundations which is required to hold the two number of columns. So generally these can be decided based upon the span between the columns. So if it is the foundation size is higher than the column spacing, then we need to go for the combined foundations. So this one is isolated foundations where the column locations is have more, maybe 5 meters or more than 3 meter or more than the width of the foundation base slab. So according to that we can decide either it is a isolated column or the combined foundations. So this is isolated foundations for complete buildings which is placing below the column. So here in this picture you can see these are the green color of the main column which is running towards the span of the building. In the width directions we can see these two pink color column. So these column are act like a wind post. In opposite to this width direction there should be some two more or single column which is also act like a wind post. So accordingly the foundations should be placed for the wind post also. So now we are in the summary of this video. We have seen column, rafter, wall tie beams, roof purlins, column cross bracings, and four number of connections, sag rods requirement, corbel beams and crane beams requirement for the lifting and the transportation of material inside the building. That is a crane requirement and the lifting hook requirement. And finally we have also seen the foundations. So these are the pictures which is related to the videos which we have discussed in this. So with this we can end this video and we will be looking more videos in upcoming. Thanks for watching this video. Look description for more related videos. Subscribe to this channel for more updates. Thank you.